triple integration, it means if f is a continuous on the rectangle box a comma b cross c comma d, a comma b cross c comma d cross r comma s, then the triple integration of f of x comma y comma z with respect to dv over d is equal to integration from a to b, integration from c to d, integration from r to s, f of x comma y comma z with respect to z, with respect to y, and with respect to x, and the iterated integral expressed in phi other different orders. तर ट्रिपल इंटिग्रेशन फाइंड करण्यासाठी हा कोणता थेरम आहे? फिव्हनीज थेरम आहे. तो काय सांगतो? इफ वी हॅव दिस रेक्टँगल box a comma b cross c comma d cross r comma s and f is a continuous function defined on this rectangle d, then integration of this function f, continuous function f, over this rectangle with respect to dv is equal to integration from a to b, integration from c to d, integration from r to s, f of x comma y comma z with respect to z, with respect to y, and with respect to x. And the other iterated forms can be expressed in the following types for this triple integration of f over d. Now we have one example on this theorem. So the example is evaluate triple integration of f of x comma y comma z dv, where this d is equal to 1 comma 2 cross 0 comma 1 cross 3 comma 4. Now we have the integration of this by using the Fibonacci theorem. So by Fibonacci theorem, triple integration of f of x comma y comma z dv with respect to d is equal to integration from 1 to 2, integration from 0 to 1, integration from 3 to 4, karan these are the rectangles. So first is from 1 to 2, in the second we have from 0 to 1, and in third we have the integration from 3 to 4, and the function is x y z dz dy dx, which is equal to integration from x equal to 1 to 2 dy dz here dx, x equal to 1 to 2, y equal to 0 to 1, and z is equal to 3 to 4. Now we have first find the integration with respect to z, and its integration is z square by 2 dy dx. Now the integration of z with respect to z is z square by 2. So here 1 to 2, integration from 0 to 1, integration from 3. Now here we have the integration is z square by 2. The remaining terms are as it is dy dx 1 to 2, 1 by 2, the limits from 3 to 4, limits are from 3 to 4, 1 to 2, 0 to 1, xy 4 square is 16 minus 3 square is 9 divided by 2 dy dx which is equal to integration 1 to 2 integration 0 to 1 xy 7 by 4. Value of this term is 7 by 4, so take outside of the integration 1 to 2 0 to 1 x. Now here x integration of y with respect to y dx, this is equal to 7 by 4 integration 1 to 2 integration of this y with respect to y is y square by 2, limits are from 0 to 1. Here x with respect to x is equal to, now value of this is, sorry, here 7 by 2, 7 by 2, and if we solve this substituting the value, first y is equal to 1 and then y is equal to 0, we get 1 by 2 into 1 by 2 integration 1 to 2 x dx is equal to 7 by 4, 7 by 4. Now integration of this is x square upon 2, 1 to 2, 7 by 4, and if we solve this we get 2 square, that is 4 minus 1 divided by 2, that is 21 upon 8. So the value of given integral is 21 upon 8. You can try with yourself for the other examples. There are some examples you can solve this with the help of Fibonacci theorem. एक्झाम्पल आहे जे तुम्ही फिबोनाची थेरम यूज करून सॉल्व करू शकता. हियर आर सम काही एक्झाम्पल देतो मी सोडवण्यासाठी, ते तुम्ही सॉल्व करा. फर्स्ट एक्झाम्पल इंटिग्रेशन 0 to 1 इंटिग्रेशन -1 to 2 इंटिग्रेशन 1 to 3 x square plus 2y plus z cube dz dy dx. Second one integration 0 to 1 integration 0 to 3 minus 3x integration 0 to 3 minus 3x minus y dz dy dx dz dy dx. And third one is integration 0 to 2 integration 0 to x integration 0 to x plus log y e to the power x plus y plus z dz dy dx. तर या तीन एक्झाम्पलमध्ये काय डिफरन्स आहे, इथं जे इंटिग्रेशनचे लिमिट्स आहेत ते कॉन्स्टंट आहेत आणि ह्या दोन एक्झाम्पलमध्ये जे लिमिट आहेत इंटिग्रेशनचे ते व्हेरिएबल्समध्ये आहेत. तर आपण सेकंड ऑर्डर डबल इंटिग्रेशनमध्ये व्हेरिएबलचे एक्झाम्पल सोडवलेले आहेत, त्याचा यूज करून तुम्ही हे एक्झाम्पल सोडवू शकता. सो त्याच्यामधलं जर आपण एक एक्झाम्पल सॉल्व करून बघितलं तर आपल्याला समजेल. तर व्हेरिएबलचे एक्झाम्पल बघण्या अगोदर काही प्रॉपर्टीज आहेत ट्रिपल इंटिग्रेशनच्या, ते आपण बघूयात. प्रॉपर्टीज ऑफ ट्रिपल इंटिग्रेशन. प्रॉपर्टीज ऑफ ट्रिपल इंटिग्रेशन. पहिली प्रॉपर्टी आहे लेट f of x comma y comma z g of x comma y comma z be two continuous functions, be two continuous functions defined on a closed and bounded region D which is subset of R cube. This is closed and bounded region, closed and bounded region. Then ह्या नेसेसरी कंडिशन आहेत की फंक्शन हे काय पाहिजे तुमचं कंटिन्युअस पाहिजे and defined on closed and bounded region D. Then first one is triple integration of alpha into f of x y z dv over this region D is equal to alpha into triple integration of f of x y z with respect to dv over this region D. म्हणजे जो आपण सिंगल इंटिग्रेशनमध्ये बघत होतो की कॉन्स्टंट इंटिग्रेशनच्या बाहेर घेतात, सेम प्रॉपर्टी इथे अप्लाय होते. नेक्स्ट वन, ट्रिपल इंटिग्रेशन ऑफ f प्लस g of x y z dv over d is equal to triple integration of f of x y z dv over d plus triple integration of g of x y z with respect to v over the same region d. This is the additive property, this is the scalar multiplication property. See, if d is equal to d1 union d2, if d is equal to d1 union d2 is expressed as a non-overlapping disjoint regions, then triple integration of f of x y z over this region d. D is nothing but union of d1 and d2 with respect to dv is equal to triple integration of f over d1 obviously with respect to v plus integration of f of x y z dv with respect to d2. So this is the happens only if d1 and d2 are disjoint, म्हणजे d1 इंटरसेक्शन d2 मध्ये एकही एलिमेंट कॉमन नसेल तर. नेक्स्ट प्रॉपर्टी आहे, if f of x comma y comma z is greater than or equal to 0 for all x y z belongs to D, then triple integration of f of x y z dv with respect to D over D is also greater than or equal to 0. म्हणजे फंक्शन पॉझिटिव्ह असेल तर त्याचं इंटिग्रेशन ही काय येणार, पॉझिटिव्ह येणार. नेक्स्ट प्रॉपर्टी आहे, if we take f of x comma y comma z is equal to constant function 1 for all x y z belongs to D, then the triple integration of f of x y z dv over d is equal to, हे फंक्शनची व्हॅल्यू काय आहे, 1 dv over d is equal to limit n tends to infinity summation I is equal to 1 to n delta vi, and this is what, volume of region D. This is equal to volume of region D. In this way we can say that triple integration is used to evaluate the volume of a region. जर मी फंक्शनला आयडेंटिटी फंक्शन 1 जर घेतला तर जो रिझल्टंट इंटिग्रेशन मिळेल तो काय असतो, त्या रिजनचा व्हॉल्यूम मिळतो. ठीक आहे, ह्या काही प्रॉपर्टीज आहेत ज्या तुम्हाला ऑब्जेक्टिव्हमध्ये विचारल्या जाऊ शकतील. तर ह्या प्रॉपर्टीजवरती आपण एक एक्झाम्पल सॉल्व करू, जेणेकरून जे तुम्हाला 3 मी एक्झाम्पल दिलेत होमवर्कला ते सुटतील. तर पहिलं एक्झाम्पल, इव्हॅल्युएट integration from x equal to 0 to 1, integration from y equal to 0 to 1 minus x, integration from z is equal to 0 to 1 minus x minus y, x plus y plus z dz dy dx, dz dy dx. सोल्यूशन सिंपल सेम प्रोसीजर आहे. capital I is equal to, suppose capital I is equal to the given integration, given integral, then capital I is equal to integration from x equal to 0 to 1, integration from y equal to 0 to 1 minus x, integration from 0 z is equal to 0 to 1 minus x minus y, x plus y plus z dz dy dx. तर आता पहिलं इंटिग्रेशन विथ रिस्पेक्ट टू काय घेणार तुम्ही, z ऑब्वियसली is equal to x equal to 0 to 1, integration from y equal to 0 to 1 minus x, याचं इंटिग्रेशन विथ रिस्पेक्ट टू z, मग x कॉन्स्टंट आहे तो एक्स झेड प्लस वाय झेड प्लस झेड स्क्वेअर अपॉन 2, and limits of the integration are from z is equal to 0 to 1 minus x minus y dy dx. मग हे सॉल्व करू. हे आहे तसं x इक्वल टू 0 to 1, y इक्वल टू 0 to 1 minus x. ह्यामध्ये काय करणार मी, z इज इक्वल टू एकदा 1 minus x minus y आणि एकदा z इज इक्वल टू 0 ठेवणार, आपल्याला रिझल्टंट व्हॅल्यूज मिळतील. सो दिस इज इक्वल टू x plus y minus x plus y bracket square plus 1 by 2 plus 1 by 2 x plus y bracket square minus x plus y dy dx which is equal to x equal to 0 to 1, y equal to 0 to 1 minus x equal to 0 to 1, y equal to 0 to 1 minus x, 1 by 2 minus 1 by 2 x plus y bracket square dy dx this is equal to 1 by 2 integration 0 to 1 y minus x plus y bracket cube divided by 3, and limits of the integration from y equal to 0 to y equal to 1 minus x dx. This is equal to 1 by 2 integration 0 to 1 1 minus x minus 1 by 3 1 minus x cube dx. And finally, if we solve this integral, or if we simplify first this, we get 2 by 3 minus x plus x cube upon 3 with respect to x. This is equal to 1 by 2. Our integration of this with respect to x is 2 by 3x minus x square upon 2 plus x raised to 4 upon 12, 0 to 1. This is equal to 1 by 2. And now if we substitute the value for x equal to 1 and x equal to 0, we get 2 by 3 minus 1 by 2 plus 1 by 12. And if we simplify this, we get which is equal to 1 by 8, which is equal to 1 by 8. So this is the value of given integral. In this way, we can find the triple integration using Fibonacci's theorem. There are some examples to find the moment of inertia of objects in R cube using triple integration. So we will discuss that in the next lecture. So in this way, we had covered about the triple integration, that is multiple integral and their applications for the double and triple integrations. So already तुम्हाला सगळ्यांना मी PDF नोट्स पाठवलेले आहेत, त्या तुम्ही बघू शकता. तर अशा प्रकारे आपला पहिला युनिट संपलेला आहे. नेक्स्ट लेक्चरपासून आपण नेक्स्ट युनिट सुरू करणार आहोत. Thank you.